Good evening, everyone. My name is Tad Larock, and I'd like to welcome you back to another Tech Talk in our series sponsored by Codesmith, Genie, and Bracklet. Tonight, we have the pleasure of welcoming Preston Caldwell to give us a brief talk about AWS. So without further ado, I'd like to pass it over to you, Preston.
Thanks for the introduction, Tad. My name is Preston, and I would like to start by thanking you all for coming out this evening. I know it's Friday, and I'm sure we're all eager to get to the weekend, so I'll do my best to keep this presentation brief yet informative. Before I begin, I'd like to start by thanking Genie and Bracklet for sponsoring this Tech Talk. Like Tad said, I'm here to speak about AWS, or Amazon Web Services, so let's go ahead and see what's on the agenda for today's presentation. So we're going to start by going over a brief introduction and history of AWS, and then jump into more specific topics regarding AWS, as you can see here. These include various service options that are offered by AWS, AWS's infrastructure and scalability, their pricing model, some of their key services, and then we'll go and touch on some brief AI and machine learning, as well as future technologies of AWS. Let's start with an overview of AWS, and over the next several slides, we'll take a closer look at how AWS and see how it more or less revolutionized the cloud computing industry. In today's world, many businesses and organizations are quite massive, with hundreds of millions of users. Startups, though, or smaller organizations, might not have as large of a user base, several of these saying 100 users or maybe even less. Either way, these businesses and organizations need a way to host their services and applications, and not only host them, but scale them depending on their real-time demand. A site's traffic can change rather unexpectedly by over 100-fold compared to what's considered typical traffic. A prime example that I'm sure we're all aware of is Taylor Swift and Ticketmaster issue that took place at the end of last year. Essentially, Ticketmaster crashed repeatedly while users were trying to buy their tickets for the upcoming Taylor Swift concert. This crashing spree resulted from a high number of users on the site, and in turn, the number of requests going through the site. It was just not something that was expected. We'll get into this a bit later, but this introduces a concept of scaling and how it can have major impacts on cost effectiveness and on the need for the physical computational power that's actually needed to run these sites and services. Problems like these are ultimately what led to the introduction of AWS. Before we get into too much detail regarding the specifics of AWS, though, let's look at a little history and understand where AWS is at now and how it got to where it is today. So let's start in 2006 with the initial creation of AWS. This obviously was a revolutionary point in time with regard to technology. With its introduction, it entirely transformed the way businesses think about infrastructure. And by this, I specifically mean by introducing this concept of on-demand cloud computing services. These first several points, as you can see here, all take place in 2006, but I think they deserve to stand on their own on this slide, as they each played a major role in AWS tech revolution. Following AWS here on this timeline, EC2 played a crucial role in popularizing the idea of scalable and resizable cloud computing. This came from its ability to run virtual machines in the cloud, which in turn provided flexibility and saved costs for users. Another major release in 2006 was Amazon S3. S3 had a major part in revolutionizing data storage by providing scalable, durable, and highly available object storage. This made it much easier for businesses and organizations to store and retrieve their data from the cloud. This concept of scalability and availability paved the way for many of today's big data and analytic applications. Moving now on the slide to 2014, Amazon released AWS Lambda, which was another groundbreaking development, this time in the realm of serverless computing. AWS Lambda allowed developers to run code in response to events without necessarily having to manage their own servers or computational resources, further simplifying the application development and scaling process. The last point in today's history lesson is the launch of Amazon Aurora in 2015. As a fully managed database service, it combined the performance and availability that high-end commercial databases offer with the simplicity and cost-effectiveness of something like an open source database. Managing database migrations and performing maintenance on these databases was no longer a concern for developers. So I know we kind of breezed through that last slide, but I wanted to show y'all this slide first and point out there's over 200 different services that AWS provides. As much as I would like to go and jump into each one of these and explain them all, I'm afraid we just don't have time for that in this presentation alone. AWS, though, provides services in a range of areas such as mobile, enterprise, administration and security, deployment and management, analytics, databases, networking, machine learning, and several others that you can see here. If you find interest in any of these areas or would just like to learn a little more about AWS, I encourage you all to look into some of these specific services and see what they all encompass. Like I said before, we'll go over a select handful of these in a couple slides. So I want to go next and talk about AWS's infrastructure. It's a central part to their success and popularity in the world of cloud computing today. With the ability to operate in multiple geographic regions around the world, the services offered by AWS are practically accessible anywhere at just the click of a button. I'd also like to point out here that there are probably more regions than those depicted here in the image. Amazon is always expanding, as I'm sure we all know. And with constant expansion comes new regions every day. Regions within this infrastructure map here are broken down into what AWS calls availability zones, which are essentially data centers within each of these regions. Each of these availability zones is designed to be physically and logically separate from the others, which results in data redundancy and fault tolerance for this user data. This ensures data and critical components of a user's application are safe in case of a failure, which makes AWS quite reliable in this nature. On the note of reliability, AWS employs a high availability architecture that is made up by these availability zones and other efforts such as elastic load balancers, data replication, resilience testers, and several others. AWS's infrastructure also encompasses topics like edge locations, which provide low latency access to cached data, as well as best-in-class data center security and disaster recovery. Again, being limited on time, I urge you all to look into some of these topics regarding AWS's infrastructure in particular. These concepts are quite interesting and are a good way to think about the real-world application of these various services that AWS offers. I've mentioned a couple times so far this concept of scalability, but I want to take this slide to talk about it and see what we think it means. Scalability in the context of cloud computing refers to the ability to handle increasing workloads. In most cases, this refers to an increased number of users or requests to the server, like we talked about with Ticketmaster. Another word I've used, elasticity, is important to discuss here as well, because while it may seem synonymous to scalability, it differs in that when something is elastic, it's automatic. It's going to expand and contract based on the force being applied to it. So a real world example of this would be a rubber band, for example. When you pull outward on a rubber band, it wants to pull inward. When you crumple it up into a ball, it wants to expand back into its original shape. So in the case of cloud computing, the force applied is the load or demand on that specific service. So to address this idea, AWS hosts a service called autoscaling that automatically adjusts the number of EC2 instances running in response to changes in demand. As you can see on the image here on the slide, there are 4 boxes inside of the larger box. If the site is calm, the minimum amount of boxes can be used, as you can see here, the 2 orange ones. If load increases those empty boxes or the dotted boxes on the screen can be then activated and used in the application. So horizontal scaling, vertical scaling, and load balancing are all central to this idea of cloud computing elasticity and is a concept that AWS is built upon. Together, these concepts are what allow these different services to work so smoothly in unison. While all these services and features sound great, it's also important to know how billing works when it comes to actually using these services. The pricing model at AWS is known for its flexibility and cost effectiveness. With their pay-as-you-go model, customers are billed only for those resources and computational power that they actually use. For example, if you have an EC2 instance, it's only running between the hours of noon and midnight, let's say. I'm not sure why only noon and midnight, but we'll go with it. Those are the hours that you're going to be charged for. So between the hours of the other 12 hours, you're not going to be charged for those. So another aspect of their pricing model that's worth pointing out is their on-demand pricing. With this, users essentially pay by the hour or second, and the key here is that there's no upfront fees. So this provides flexibility to spin up and shut down resources without worrying about being charged for additional fees. Last on our pricing discussion is the idea of reserved instances, which enables user to ultimately reserve instances and resources and computational power for a specified period of time in exchange for a significantly reduced cost per time. So this aspect of pricing specifically is more geared towards those organizations that have a predictable workload, but when it's applicable to use them, it's much appreciated by those who are able to actually take advantage of this cost implementation. I want to come back around and talk a little bit more about some of AWS's most popular services today. Starting with EC2 here, or Elastic Cloud Compute, it is a core service within AWS that provides scalable and resizable virtual machines, also called instances, located in the cloud. These instances come in several types depending on the needs within the specific workload. Examples of these types could include compute-intensive, memory-intensive, storage optimized, and several others. One of the key advantages of EC2 though, is its flexibility. EC2's flexibility allows users to choose specifications such as their operating system, instance type, storage options, and even network configurations. EC2, of course, takes advantage of AWS's infrastructure that we saw in the previous slide, so these instances can also be launched in multiple regions around the world and into each of those availability zones that we saw. Again, this ensures those concepts of high availability, redundancy, and fault tolerance that are so highly desired in an application. Looking at RDS now, RDS is a fully managed database service offered by AWS that more or less simplifies database administration tasks. These tasks include provisioning, patching, backing up data, recovery, and scaling. RDS supports several popular relational database services such as MySQL, PostgreSQL, and Oracle. RDS also supports this concept of multi-AZ deployments, as well as read replicas, which ensures high data durability and availability within that user's RDS database. With these quality assurances and protocols in place, RDS plays a major role in reducing the amount of operational overhead needed to manage a system of complex databases. Following RDS on this page here is S3. Like I said before, S3 played a central role in revolutionizing S3 played a major role in revolutionizing data storage. In this specific situation for S3 is termed simple storage service, and it is an object storage service that allows users to store and retrieve virtually unlimited amounts of data in a highly scalable and durable way. As one of the most reliable storage options available today, it offers a durability rating of 99% with 11 nines following in the decimal position. That's incredibly durable. S3 also allows for a wide range of data types, from documents to images to videos to entire system backups. That's pretty impressive, as all this data can then be accessed over a simple RESTful API link, which I consider to be rather convenient. Last on our slide for services is AWS Lambda. Lambda essentially is a serverless cloud compute system that allows users to run code in response to particular events, like I said earlier, without having to manage their own servers. Events that are able to trigger these Lambda functions include HTTP requests, database updates, file uploads, etc. This range in functioning triggering events enables developers to create highly responsive and efficient applications. Like with the other AWS services, Lambda is built to scale and in turn can handle a single request or thousands of requests in a single second. So let's move on to the next slide and talk about some of AWS's AI and machine learning initiatives. So the concept of AI and machine learning topics are massive today, and I want to at least touch on them here. Starting here with range of services. AWS has an extensive array of AI and machine learning services, from recognition, which is used for image and video analysis, to SageMaker for custom model development. With these services, AWS empowers organizations to tackle challenges in areas such as computer vision, natural language processing, recommendation systems, and much more. Whether you're in healthcare, e-commerce, finance, or even construction, AWS is bound to have a service that you could use or your company could use to benefit their needs. As for managed services here, AWS is pretty much manages everything for you, as with everything else we've talked about so far in this presentation. With these AI models, AWS ensures that you don't have to provision, scale, or maintain your servers. All these operational intricacies are taken care of, which leaves us, the developers, with more time to do things that actually matter, which is building things. AWS also offers services in the areas of natural language processing, which I think is a fascinating area to work in. An example of one of these services would be Amazon Comprehend, which allows you to extract valuable insights from unstructured data with ease. From sentiment analysis to language translation, it provides a massive insight and understanding and leveraging text-based information. Another service in this area, Amazon Lex, plays a major role in simplifying the implementation of conversational interfaces and chatbots. This ease of implementing a chat model into an application through AWS is rather simple, and it's one of the reasons why Lex is so popular today. Last on this slide is the topic of Edge AI. For those of you who are not entirely familiar with this concept, Edge AI is basically the distribution of AI resources, computational resources specifically, to regions around the world where data can be closer to those devices that actually need the data. With AWS Greengrass, for example, we can do just that. AI models can be placed closer to the data source, resulting in enhanced real-time processing, which, when you think about it, is incredibly important for things like self-driving cars and industrial automation. We wouldn't want anything going wrong because of a slower time. Okay, so as we look into the future of cloud computing and technology in general, it's rather overwhelming to think about all the potential out there. No one knew cars would be a thing until they were, and now we have cars that drive themselves. So it's exciting. It's an exciting field to be in, and an exciting time to be in it. Between quantum computing, research, and development with applications like AWS Bracket, serverless evolution, with tools such as Lambda, edge AI innovations, satellite and aerospace solutions, and just AI in general, AWS is paving the way for a very promising technological future. While I don't have much information on this slide specifically, I added it here because I wanted to get you all thinking about what's possible today, or even tomorrow, given the technologies at our disposal, such as those offered by AWS. Having reached the end of the material for this slide, or for this presentation, I wanted to review some of the bigger points that we discussed today. First, AWS offers an incredibly wide array of over 200 services, including services in administration and security, deployment and management, networking, analytics, and several others that we mentioned earlier. All in all, AWS is bound to have a service that you or your company could benefit from. We then went in and talked a little bit about AWS's pricing model and what all that entails. It basically boils down to the fact that you only have to pay for what you use, and I personally think that's pretty fair. There's no upfront fees, no charges for stopping and starting instances. It's a big reason AWS is so respected and appreciated. We also talked a little bit about AWS's infrastructure and the fact that it's incredibly reliable, accessible, and scalable. With an ever-changing increase in the number of availability zones around the world, safeguards in place to increase redundancy within this data, and the ability for instances to scale automatically, it's no wonder AWS has more than 1 million active users around the world. So here is my work slided, and like I said before, if you're interested in any of these or would just like to learn a little bit more about AWS, I encourage you to look around and see what all these services are capable of. Now in the presentation is the point where I would usually ask if anyone has any questions, but looking at the time now, it seems like we've run a little over on time. And because that's the case, if you all have any questions or regarding today's material or anything else software related or anything at all, honestly, I encourage you all to reach out to me through either my LinkedIn that you can see here or through email. I'd be happy to chat over just about anything. I want to thank you all for coming out to watch this presentation, and I look forward to reading any questions you all may have. At this time, though, I'll go ahead and close and pass it back to you, Tad.
Thank you so much for that informative talk, Preston. And thank you everyone for coming out tonight. We'll see you at the next one.